Hello viewers, this is Mahmood, and in this video we are going to solve question number 9 of exercises 1.1. The question is, express the area and perimeter of an equilateral triangle as a function of the triangle's side of length x. In this question we are going to express the area and the perimeter of an equilateral triangle is represented by the function of the triangle side of length x. Okay, so you know that what is an equilateral triangle? So equilateral triangle is a triangle in which all the three sides are equal in length. Okay, so let the length of this side means the length of the base is x. Similarly, the length of this side is also x, and the length of this side is also x. And we know that the perimeter is basically the boundary of two-dimensional figure. So here the length of the boundary of the triangle is basically the sum of these three lengths. Okay, so here let me denote perimeter by p. So perimeter is equal p. So we have here p is equal the sum of the length of the sides. So here we have x plus x plus x. So this is the sum of the length of the three sides. So that gives us the perimeter of the triangle. So here we have p is equal 3x. Okay, and now you can see that p is a function of what? P is a function of x. Okay, or we can also write is a function notation just like p of x is equal 3x. Okay, so we expressed the perimeter of an equilateral triangle as a function of the length x. Okay, now the second part is we have to express the area of the equilateral triangle as a function of the side length x. Okay, so we know that what is the area of the triangle? So the area of a triangle is 1 upon 2 base time the height. Okay, so now what's the height of this equilateral triangle? So let me draw the altitude here. This one. So you can see that this altitude divides the base into two equal parts. Okay, so clearly this length, this is going to be x divided by 2. Okay, so we have to use the Pythagorean theorem here, and you know that the altitude, the length of the altitude is h, that is height of this triangle. So by Pythagorean theorem, what will be our h? So here, so this is going to be the hypotenuse square, that is x. So x squared equal the base square, so that is going to be x divided by 2 square, and then plus height square. Okay, but here we are going to find the value of h. So shift the first term to the left side, so we get h square is equal x squared minus x squared upon 4. Okay, so by simplifying we get the value of h square, that is 3x squared upon 4. Now we have to take the square root on each side, so the value of h will become plus minus square root of 3 divided by 2 into x. So we have to neglect the negative because the value of h represent the length. Okay, so we have h is equal square root of 3 divided by 2 into x. So this is my h. Got it? Now put this value of h into the formula of area. So you can see here the area A is equal 1 upon 2. What is my base of this equilateral triangle? So my base is x, so we have to put x here. And then what is my height? So the height is square root of 3 divided by 2 times x. Okay, so area is going to be equal square root of 3 divided by 2 times 2 is 4, and then x times x is going to be x squared. Okay, or in a function representation we have to write a of x is equal, okay, let me write here, a of x is equal square root of 3 upon 4 into x square. So this is basically the area, and that is basically a function of x. Okay, let's move to the next question, question number 10. That is, express the side length of a square as a function of the length d of the square's diagonal. Then express the area as a function of the diagonal length. Okay, so let's say this is our square, yeah, and let's suppose this is the diagonal. This is the diagonal of the square, and let me call the length of this diagonal is small d, and the side of the square, let's say that is small s, so this side is also s, and all the four sides will be s because it's a square. Okay, now we have to express the side length of a square as a function of the length d. Okay, so we have to use a Pythagorean theorem here. You can see the hypotenuse square means the d square is equal this side square plus this side square, means the perpendicular square plus the base square. So that is s square plus s square. Okay, so here we have d square is going to be equal 2 times s square. Now we have to take a square root on each side by neglecting the negative sign because we are discussing the length. So d is equal square root of 2 times s. Okay, now we have to show, the side length is a function of the diagonal. Okay, so we have to find the value of s here. So s is equal 1 divided by square root of 2 times d, or in a function notation we can write s of d is equal 1 divided by square root of 2 d. Got it? So we expressed the side length of a square as a function of the length d, means the diagonal. Okay, so now we have to move to express the area as a function of the diagonal length. Okay, so we know that area of a square is basically, the length multiplied with, that is s times s, that is s square, means s multiply s. So the area is going to be equal s square here. And now the value of s is, that is, here we have 1 divided by square root of 2 into d, and then take the square here. So the area is going to be equal 1 divided by 2 into d square, or so area is a function of the diagonal d, so area a of d is equal d square divided by 2. Okay, so this is basically the area that is expressed as a function of the diagonal d. Okay, now question number 11, that is, express the edge length of a cube as a function of the cube's diagonal length d. Then express the surface area and volume of the cube as a function of the diagonal length. So let's say we have a cube and we know that cube has 6 square faces and 12 edges. Okay, so let the length of each edge is s. Okay, so the length of this edge is s, the length of this edge is s, similarly the length of this edge is also s. Okay, because it's length, width and height of the cube. Okay, now we have to make a diagonal. So you can see here, this is going to be, we have to join this vertex to the opposite vertex here. So this is going to be the diagonal of this cube. Okay, so let the length of this diagonal is d. Got it? Now let me explain it more precisely. You can see here we have a cube. So the main diagonal is, you have to join this vertex to the opposite one. So this is going to be our diagonal, and you know that the length of this diagonal is d. Okay, now we are going to on the base, just like this one, we have the base of this cube, that is just like this is going to be the base of this cube. Okay, so now the diagonal of the base is going to be this one. So we have to join, we have to join this vertex to this one. Okay, so this is the diagonal of the base. Okay, so let me call the diagonal of the length of the diagonal of the base is, let's suppose that is our d1. Okay, so now how to find the d1 here? So again we have to use the Pythagorean theorem. This is one side of the base and this is the other side. Okay, and we know that the length of this side, this edge is s, similarly this is also s. Okay, so now what is my d1? So you can see we have to use the Pythagorean theorem here. So that would become d1 square is equal s squared plus s squared. Okay, and you can see here, so d1 square is going to be 2 times s squared. Okay, so now when we take the square root on each side, so it will become d1 is equal square root of 2 times s. Okay, we have to neglect the negative because it's a length. Okay, so d1 here we have square root of 2 times s. Okay, now consider this edge here by joining these 2 points. Okay, and you can see here the length of this edge is also s. Okay, so now we are going to calculate this d. So how to calculate d? So again using Pythagorean theorem, so that is d square is equal d1 square plus s square. So here d square is equal, what is my d1? That is square root of 2s. So we have to take a square, so square root of 2s whole square plus s square here. So d square is going to be equal, it is going to be 2s square plus s square. So d is going to be equal 3s square. D square is equal 3s square. Now we have to take a square root. So the value of d is going to be square root of 3 into s. Okay, so this is basically the main diagonal of the cube. Got it? Again we have to consider the positive because we are discussing the length. Okay, now so d is going to be equal square root of 3s. So now in the question we have to express the edge length of a cube as a function of the cube's diagonal length d. Okay, so now the first part, that is, the diagonal is going to be equal to square root of 3 times the edge length s. Okay, so we have to express the edge length as a function of the diagonal length. Okay, so that is going to be solve this equation for s. So you will get 1 divided by square root of 3 into d. Write in a function notation, so that is s of t is equal 1 divided by square root of 3 d. Got it? So this is a function of d. Okay, now the second part, then express the surface area and the volume of the cube as a function of the diagonal length. Okay, so now the second is the surface area. So as I told you earlier that the cube has 6 faces, 6 square faces. So the surface area, let me call surface area by, let's suppose, by m denote the surface area of this cube. Okay, so that would become 6 times the area of each square, so that is s square. Here we have, this is our first face, let's say the front one. So the area of this front face is s square. So we have 6 faces, so all of them, of area s square. So we will multiply with 6. So that is going to be m is equal 6s square. So here m is equal, what is my s here? So my s is 1 divided by square root of 3 times d square. Okay, so now simplify this one, so you will get 2 times d square, or we can write the function notation, that is m of t is equal 2 into d square. So this is our surface area, that is a function of the diagonal d. Got it? Now the third part of the question is, we have to express the volume also as a function of the diagonal length. Okay, we know that the volume is basically equal length multiply width multiply height. So here the length is s, the width is also s, and the height is also s. So the volume is going to be s cube. So just put the value of s here. So v is equal, what is my s? So that is 1 divided by square root of 3 into d to the power 3. So v is equal d to the power 3 divided by 3 power 3 divided by 2. Or in the function notation we can write v of t is equal d cube divided by, so 3 power 3 is 27, so square root of 27. So this is going to be the volume, that is a function of the diagonal length d.